In this video, I'm going to teach you how to install animated LED lights into your cosplays, just like I have on all of these cosplays. So if you want to know how to install animated LED lights into your cosplays, let's get into it. Alright, so these are all the different materials that you're going to need in order to install animated LEDs into your cosplays. First off, you're going to need the circuitry components. This is an Adafruit Metro Mini. This is the board that I use for all of my animated LEDs. Next, you're going to need the Power Boost 500C or the Power Boost 1000C. This is a Power Boost 500C. This is actually what's going to be connecting the battery to the circuit. Next, you're going to need some LED lights. I've got a spool of LEDs here. These are 3-pin LEDs. As you can see, there are 3 little spots here between each individual LED. These are individually addressable LEDs, and that third spot right there in the middle is gonna be what allows you to add a bunch of animations to your LEDs. Next, you're gonna need some wire. I actually have 2 different kinds of wire here. This is normal, non-solid core wire. It's just your standard red and black cable. I'm going to be using this to connect the LEDs to the circuitry components. However, I'm also going to be using some solid core wire. The inside of this wire is one solid piece, whereas the inside of this wire is not one solid piece. I tend to prefer to use solid core wire when attaching wires to the circuitry components themselves. Next, you're going to need a soldering iron and some solder. This is the one that I use. It is Rosen solder wire. A couple of the other things that you're going to need are a wire stripper, as well as a pair of scissors. Some helping hands are always helpful, pun intended, for holding the different parts that you need to solder together. You're also going to want some way of cleaning your soldering iron. So once this guy gets real hot, I just kind of dip it in here real quick, and it cleans off all the hot solder off of the tip of the soldering iron. And lastly, we're going to need this tiny little guy here with 3 little legs on it. This is a slide switch. This is going to be very important because it'll allow us to turn our lights on and off once they're installed. There are also a couple of optional things that you could have that will probably make your life a little bit easier in the long run. One of those optional things that I'm going to be using is shrink tube. This is a tube of rubber that shrinks up around exposed wires. So I'm actually going to be using these when I attach wires to the switch and any wires together to prevent any sort of wiring from being exposed in this circuit. And then I'm actually not going to be using these helping hands. I'm going to be using these helping hands. These are a little bit sturdier, a little bit larger, and just generally easier to work with. The traditional helping hands that you'll typically see are these smaller ones, but I personally like using these helping hands. So without further ado, let's get into the actual circuit building. So the very first thing that I always do when creating LED circuits is connect the Power Boost 500C to the Adafruit Metro Mini. And to do that, I find the 5-volt and the ground pins on the Adafruit Metro Mini. And I also find the plus and negative pin on the side of the Power Boost 500C. So I'm going to be connecting the 5-volt pin on the Adafruit Metro Mini to the positive pin on the Power Boost 500C, and I will be connecting the ground pin on the Adafruit Metro Mini to the negative pin on the Power Boost 500C. To do that, we need 2 lengths of wire. I'm going to be using solid core wire for this. You can use either solid core or non-solid core. And by the way, the weight of this wire is 22 AWG. That is the weight that I've found works best with these particular circuitry components. So what I'm going to do is actually take the wire stripper and strip off both ends of each of these wires. Once you strip off the end of the wire, you can see there's a bit of exposed wire there at the end. And that's what's going to be connected to your circuitry components. So I'm going to take the Metro Mini first, clip it to one of my helping hands here, take my black wire and put that in the ground pin on the Metro Mini and clip the wire between the other clamp of the helping hands. Next, I'm going to be taking my soldering iron and some solder, and I'm just going to put a little bit of solder right over top of that wire in that pin. Clean off my soldering iron tip, and now that wire is secured. I'm going to be doing the exact same thing with the red wire here, except this is going to go to the 5-volt pin, a little bit of solder, and now both of those wires are secured to your Metro Mini. Now you're going to put your Power Boost 500C onto your helping hands. I'm going to take the Metro Mini with the 2 attached wires, and now I'm going to put the black wire into the negative side because that's what's connected to the ground side on the Metro Mini. Clip that in and solder it in. I'm going to take the red wire, put it in the positive pin, clip that in, give it a little bit of solder, and now the Power Boost 500C and the Adafruit Metro Mini are connected. One thing that you may want to watch out for, especially if you're not using solid core wire here, is that there is some excess wire hanging out from the back of each of these pieces. You might want to go ahead and clip that with some scissors, especially if it's not solid core, because those wires can actually cross behind the circuitry and you wouldn't even know it, and it could cause some short outs, and just nothing good happens when wires cross. The next step in creating your LED circuit is actually going to be installing the switch. There are 3 pins on this switch, which means you need 3 lengths of wire, and these pins are going to be connected to 3 ports on your Power Boost 500C. They are labeled BAT, EN, and ground. Now it doesn't matter which wire goes where, except that your middle wire definitely needs to be connected to EN. So I'm going to take 3 lengths of my solid core wire. It's important to note that the wire color actually doesn't matter as to where you put it. It's more for just color coding so that things are easier for you in the long run, because the wires themselves don't have a charge until they're installed into your circuit. So we're going to do the same thing, just strip both ends of each of these wires. And now that all the wires are stripped, we can go ahead and install them. I'm going to go ahead and put the Power Boost on the helping hands. But I'm going to put my red wire to BAT, which stands for battery. Clip that into the helping hand right there. Give it some solder. I'm going to put my black wire here to ground, solder it in, and then my yellow wire that I have right here is going to go onto EN. Once those are all done, we just need to attach the other sides of those wires to the switch. I'm going to go ahead and put this switch on my helping hands. And this is actually where the shrink tubes come into play. I'm going to take one of these shrink tubes, cut it into 3 pieces, and attach each of those 3 pieces to each of these 3 wires. Go ahead and slide on those shrink tube onto each of these wires here. Now I can line up my wires with my switch. Once I get these wires lined up, I can go ahead and make sure to thoroughly coat both the pin and the wire with some solder. We want to make sure we have a good connection here. And then once we've made our connection, we can slide that piece of shrink tube up and over the pin. Now to get this shrink tube to shrink, we need to hit it with some heat. So I'm going to break out my heat gun here and go ahead and turn it on. And just like that, the shrink tube has shrunk to the wires. You can't move it anymore, it won't slide anywhere, it's nice and shrunk on there. I'm going to repeat these steps with the yellow and black wire, but I'm going to make sure that this yellow wire that's connected to EN goes to the middle pin and the black wire goes to the other pin. Okay, now that all 3 of these wires have been connected to the switch, we can actually connect both our Power Boost 500C and our Metro Mini to the LED lights. I have this spool of individually addressable LEDs here. You want to make sure you have 3-pin LEDs so that you can program any animation that you want into these LEDs. And this big LED strip can be cut in between each of these LEDs. So I'm going to cut a length of 5 LEDs. I'm going to cut it right on the cut line, right between these 2 LEDs. Now, whenever you work with LEDs, you want to make sure that you're following the arrows on the LEDs themselves. The arrows on the LEDs point to how the electricity is supposed to flow through them. So if you install them backwards, your LED circuit is actually not going to work. And the 3 pins on these LEDs say 5 volt, ground, and DIN. That DIN pin in the middle stands for data in. And as you can see on the other side of the LED, or on the other side of each of these LEDs, there is a DO, which stands for data out. That's going to be connected to your data cable. So the 5 volt and the ground pin are going to be connected to the Power Boost 500C. And they are going to be connected to the 5 volt and ground pins on the Power Boost 500C. Whereas the data cable is going to be connected to the Metro Mini. And as you can see, there are a lot of different pins on one side of your Metro Mini. Every single one of these pins is a data output pin. So it really doesn't matter which one you choose. I'm gonna choose data pin number 8 because that's my favorite number. And of course, we're gonna need some wire to connect this LED strip to our circuitry components. I'm gonna be using the non-solid core wire for this part. I've noticed that using solid core wire on the actual LED strips themselves tend to not stick very well, and when they come up, they actually take these little conductor pads with them, so that completely ruins the LEDs, and they're unusable after those little connector pads are gone. So that's why I'm using non-solid core wire for this. I'm gonna cut a decent bit of wire here, and I'm actually gonna cut 2 of these same length of wire. You'll see why in just a second. So since we need 3 wires, I'm actually gonna need to split one of these lengths of wire in half. And thankfully, these guys separate pretty easily. You just have to separate the black from the red and pull it apart. I'm gonna use the secondary black wire as our 3rd data input wire. So these 2 wires are gonna be connected to the Power Boost, and this wire is gonna be connected to the Metro Mini. What I'm gonna do is actually partially separate both ends of the 2 wires that are still together, and I'm going to wire strip each end of this wire as well as the other wire. And once we actually get into this wire here, you can see a lot better how much different this is from the solid core wire. So this has a bunch of little mini wires inside basically, whereas the solid core wire is just one solid piece. So I actually really like to twist these wires so that they bunch up together better, and so that they're a lot easier to work with when I'm trying to put them through the pins on the Power Boost. So I'm going to go ahead and attach the Power Boost to the helping hands here. I'm going to attach the red cable to the 5 volt pin here and make sure to secure that with the other helping hand. A little bit of solder. I'm going to do the same with the black cable on the ground pin. Now I'm going to attach the Metro Mini to the helping hands, and I'm going to go ahead and find pin number 8 and attach our cable. And now I'm going to be taking the LED strip, attaching it to the helping hands, and lining up that red cable with the 5 volt pin on the LED strip. I also want to make sure that the arrow on the LED strip is pointing this way, because the data and the power from these wires is coming from this way, going out that way. Go ahead and hit this with a little bit of solder. I'm going to repeat that process with the black wire going to the ground port and the data cable going to the data in port. Alright, and now that all 3 cables have been attached to the LED strip, the circuit itself is complete. Definitely give yourself a huge pat on the back for completing your first LED circuit. Now the next step is to actually plug this into your computer and make sure it's all good. So you're going to want to plug your Metro Mini into your PC using a USB to USB Mini cable. When you plug your Adafruit Metro Mini into your computer, both your Metro Mini and your Power Boost should light up. And now I'm going to open up a program on my computer that's going to let me add animations to these LEDs. This program is called Arduino. And I'll go ahead and leave a link in the description on where you can download it. You can download it absolutely for free. This is a software you're gonna need to be able to put all the animations on your LEDs. So once you open up Arduino, the first thing that you're gonna wanna do is go to this tab that says Tools. You're gonna look under this tab that says Board, and you're gonna wanna select Arduino Uno. You might be tempted to select Arduino Mini since we are working with the Arduino Metro Mini. However, the Arduino Mini and the Metro Mini are not compatible with each other in this software. The Metro Mini and the Arduino Uno are, so go ahead and select the Arduino Uno out of the boards list under the Tools tab. And while you're under the Tools tab, the next option under the board is the port. So when you plug in your Metro Mini to your computer, it's going to be recognized as a port. And you're gonna wanna make sure to select that Metro Mini as basically your output port for all of your coding that you're gonna be putting into it. On my computer, it always comes up as the second port that shows up, so in this case, COM4. You may only have one option, and that's fine. That would be your Metro Mini. However, my computer recognizes another device as a different COM port, so COM4 is the one that I need to select. So I'm gonna go ahead and select that. And now that you've selected both your board and your port for this project, it's time to look at some coding to animate your LEDs. So next you're gonna wanna navigate over to the File tab. And under the File tab, you're gonna see this thing that says Examples. A bunch of built-in examples are gonna come up, but you're gonna want to go scroll all the way down to the one that says Adafruit NeoPixel and select the one that says Strand Test. That's gonna open up in a different window, and you're gonna see a lot of code going on here. This code is actually just a bunch of different animations that it will cycle through once we send it to the Adafruit Metro Mini. You really don't need to pay attention to much of this. However, there are a couple lines of this code that we're gonna need to change. So right here where it says define LED pin, it defaults as number 6, but if you remember, we actually used port number 8 on our Metro Mini. So this LED pin line here is telling the code which pin on the Metro Mini to send this code. So we're gonna wanna change that from 6 to 8. Or if you used a different pin, change that number to whichever pin that you used for your project. And the next line of code that we might need to change here is this define LED count. It defaults at 60. In my case, I only have 5 LEDs connected to this Metro Mini. So while I don't need to change it from 60, I'm gonna go ahead and change it to 5 since I know how many LEDs I have connected to my board. And once you have your port selected, your board selected, and your code adjusted, you can go ahead and navigate over to this little upload button here. And once you hit that upload button there, it will tell your Metro Mini how to animate these LEDs. So let's go ahead and hit upload and see if our circuit works. And just like that, it is cycling through a bunch of different animations, and that means our circuit is functional. From here, you can do a variety of things. You can upload a completely different code into your Metro Mini to get a very specific animation that you want. You could also just adjust strand test to reflect exactly what you want it to do, since there are a variety of different animations cycling through right now. I'm actually going to show you how to adjust the strand test code so that you can isolate one specific animation that you want. So for this example, I'm going to go ahead and focus on this color wipe section right here. A color wipe is when one color starts on the first LED and slowly wipes to the rest of them, and then all the LEDs stay lit. So to achieve this goal, what we're going to need to do is a little coding trick here. So if you can see on some of these lines right here, there are 2 slashes before these lines. Those 2 slashes basically deactivate each line of code that they're in front of. So essentially what we're going to be doing is putting 2 slashes in front of every single line of code that we don't want. So for example, we don't want this theater chase code right here. So I'm gonna go ahead and put 2 slashes right in front of that. And as you can see, when I put those 2 slashes in front of the text, it actually makes the text gray. So it shows you that it's no longer active text. So it's no longer active code. I'm gonna go ahead and do that for the rest of these animations here. And once I'm done putting those 2 slashes in front of each line of code that I don't need, it should look like this. At this point, the only line of code that we're really left with is this middle color wipe animation. So all we're left with is a green color wipe here. So I'm gonna go ahead and press upload and make sure that I didn't miss any lines of code, and to make sure that this color wipe is gonna work as intended. And look at that, we have a green color wipe. It lit up pretty quickly, but it did start at that first LED and go to the last LED. So that means that we adjusted our code correctly, and this color wipe is displaying accurately. Now, another really cool thing that we can do with this coding within this color wipe is we can actually change the color of it if we want to. So, if you see this 0, 255, and 0, that is 0 on the color red, 255 on the color green, and 0 on the color blue, as in RGB for RGB LED lights. So if we were to adjust any of these values, it would actually change the color of the LEDs. So let's say I wanted some sort of purple. I'm gonna go ahead and say 0 on green, but purple is a mixture between red and blue. So 255 on both red and blue. I'll go ahead and press upload, and let's see what color this gives us. And just like that, we have a really cool purple colored light. So now that we've verified that our animated LED circuit works, and we know how to adjust code to get the animations we want, the last piece of this puzzle is to get a power source. So when it's plugged into your computer, that is a power source in and of itself. However, when it's not plugged into your computer, you're gonna need a battery to power this thing. I use lithium-ion batteries. I tend to use this 3.7 volt, 2500 milliamp, fairly flat battery. I've found that this battery is a lot easier to hide within cosplay armor than a chunkier battery like this 3.7 volt, 4400 milliamp dual battery. I have also used batteries like this when I need a little bit more power. However, these guys are a lot thicker than these 2500 milliamp batteries, so it does make them a lot harder to conceal within your armor pieces. Now, when you're deciding which battery is best for your project, definitely take into consider how many milliamps the battery has, because the more milliamps it has, the more lights it's going to be able to power, as well as the voltage, because the higher the voltage you have, the longer your battery is going to last. So if you have a circuit with 150 LEDs on it, you might want to go with something larger than a 3.7 volt, 2500 milliamp battery. However, for most projects, this battery will be sufficient and will last you for several hours. Another thing to consider when buying a battery is you want to make sure that it has a JST connector. This is the type of connector that's on your PowerBoost 500C, and is the type of connector that you definitely need to be able to connect your battery to your PowerBoost 500C. So to power up this circuit without your computer, all you're gonna need to do is take your PowerBoost 500C, find this larger connecting point, and go ahead and put the JST connector from the battery into that connecting point. As you can see right here, the lights come on no problem. The last piece that we have to test with this circuit is actually the switch. So if I slide this switch, it should turn right off. And it does. And if I slide it back, the animation starts over. And there you have it. That was how to make an animated LED circuit for your cosplay armor. If you enjoyed this video, please be sure to like this video and subscribe to my channel for more tutorial videos just like this. And definitely drop a comment. What was your favorite tip from this video? Also, what other kinds of tutorials do you want to see? I was definitely excited to share all of these tips with you, and I will see you guys in the next video.